Hi guys, next previous section we have discussed about the working instrumentations of the flame emission spectroscopies. Now we are going to discuss about the working of the flame emission spectroscopies. Here we have already shown that the how the spectra is to be determined by using the mirror, detector, monochromators and the amplifier which is to be amplified and the recorded. Here the diagram which represents the samples to be detected as a flame photometry. The samples are from the compressor, fuels, mirror, lens which to be slit and the filter, and the last the final product which to be a photo detector. So working of the flame photometer, working, that is, air at a given pressure is passed into the atomizer. The suction so produced draws some solutions of the sample into the atomizer. Air plus sample solution is then mixed with the fuel gas in the mixing chamber. The air plus sample solution plus fuel gas mixture is then burnt into the burner. The radiation emitted from the burner flame is passed successively through the lens, filter, detector, amplifier and finally into the recorder. So by using this recorder we can detect the record samples. By the above experiment is first carried out using a series of standard solution and the recording for each solution is noted. The graph is drawn between the concentration against intensity of emitter light. The test solution is taken and the similar experiments is carried out. From the graph, the concentration of the unknown samples can be determined. So the graph is shown, that is to be determined for volume of sodium chloride, and the emission spectra for concentration of sodium chloride is the unknown samples. Next, the applications of the flame photometries. What are the applications which has to be given, that is estimation of the sodium by flame photometry. So to estimate the sodium samples by using a flame photometry, the detectors how we can detect, that is the instrument is switched on, air supplies are regulated. First the distilled water is sent and ignited is started. After the instrumentation is warmed up for 10 minutes, the instrument is adjusted for 0 readings in the display. Since sodium produces a characteristic yellow emissions at 589 nanometers, the instrument is set as lambda max equal to 589 nanometer and the readings are noted. A series of standard sodium chloride solution, that is 1, 2, 3, 4, 5 ppm is prepared and is sent one by one and the readings are noted. The calibration graph is drawn between the concentration versus intensity of the emitter light. A straight line is obtained. Now the unknown sodium chloride solution is sent and the reading are noted. Then the concentration of the sodium in the water sample is determined from the calibration curve. So the calibration which has shown that the concentration of sodium chloride versus emission and the unknown samples for the concentration of sodium chloride. So here the quantitative analysis has been shown for the elements of group 1 and 2. Potassium, sodium, lithium, calcium, magnesium, etc. can be detected visually from the color of the sample solution in the flame spectrometer. Here we can use the elements in the group by for using a elements, that is calcium, lambda max 422 nanometer, color of the flame is a brick red, and the elements K, lambda value is a 766 nanometer and the color of the flame is a red. Sodium elements 586 nanometer and the color of the flame it should be in the yellow. Lithium elements it should be as a 670 nanometer and the color of the flame is a scarlet red. Non-radiating elements such as a carbon, hydrogen and halides can be detected using this method. Next one is a quantitative analysis. The amount of elements of the group 1 and 2 alky and alkaline earth metals can be determined from the samples. B. Certain transition elements such as a copper, iron and manganese can also be determined. Other applications which have been seen that the measurement of these elements is a very useful in medicine, agriculture and plant science. Flame photometry is extensively used in the analysis of biological fluids and tissues. The limitations of the flame photometry: it cannot be used for the determination of all metals, atoms and inert gases. Only liquid samples must be used. It does not provide information about the molecular form of the metals present in the original samples. So now today we have discussed about the flame photometry, how the flame should be emitted for the unknown elements for using the sodium, and the applications and the limitations for flame photometry we have discussed today. So thank you.